Hi, welcome to our channel. Today, we will show you how a tennis ball is made and packed. Mostly, we see and appreciate the technique of the player during a tennis match, but what we often overlook is the technical precision of the ball. Tennis ball is an essential part of the game and is expected to perform to extremely high technical standards, bouncing and flying through the air with perfect consistency. Have you ever wondered how the fuzzy little yellow tennis balls are made? The manufacture of a tennis ball is something of a manufacturing marvel. The tennis ball is the most complex ball we make, says Jason Collins, Global Product Director at Wilson, because of the tightness of the specification, weight, size, hardness, rebound. The materials have to be super consistent. According to an expert, Bill Dillon, 95,000 balls are needed annually for the US Open in New York City. So, let's dive straight into the video. How tennis balls are made and packed. But before we move on, please subscribe to our channel and hit the bell icon so you won't miss any of our upcoming videos. The processes of making tennis balls have barely changed during the last 100 years. The various processes are described in this video, detailing the manufacturing process of a tennis ball from start to finish. Stage 1. Productions of solutions. The rubber material used in the tennis balls is called ribbed smoke sheet rubber, which actually comes from the rubber trees of Thailand. The raw rubber comes into the factory in bales of 70 to 150 pounds. The rubber is then masticated to make it softer and to ensure that subsequently the solutions will flow correctly. A variety of powders are also used to the rubber to give the required properties to enable it to cure. After that, the rubber compound is put into a tank with a quantity of petroleum solvent and left to soak. The sticky dough results after a few hours. The dough is then diluted by stirring with more solvent until a solution of the required consistency is produced. Stage 2. Formulation. Core formulations for pressurized balls are based on natural rubber containing a high loading of fine particle filler for low gas permeability. A formulations is as follows: natural rubber 72, butadiene rubber 28, clay 40, calcium carbonate 20, magnesium carbonate 8, sulfur 3.5, zinc oxide 2.5. Stage 3. Extrude. At this stage, the rubber compound is heated and extruded by being orificed under pressure to form a rod, which is then cut into pellets. These pellets are then cooled. Stage 4. Form. The pellets are then loaded into a hydraulic press, which forms them into hemispherical or half shells and partially cures them, typically for 2.5 minutes at 150 degrees Celsius. It is to be noted here that if it is not cooled to 127 Fahrenheit, the core could explode upon opening the machine. After that, the half shells are removed from the press, joined together in a sheet by the flash which has spread out of the molds during the forming. The flash is removed by a hydraulic press fitted with cutting knives which remove the half shells from the sheet. Stage 5. Edge buff. The edge of the half shell is roughened with a grinding wheel to provide a key for the adhesive, which is next applied, so that vulcanizing rubber solutions is applied to the edge of the buff half shell. Number 6. Cure and inflate. For pressurized balls, there are two techniques of inflating or pressurizing the ball. The first technique is by the use of chemicals. This process can also be controlled, and the inflation occurs after the core has been assembled. These inflation chemicals are sodium nitrate and ammonium chloride, which actually produce nitrogen during the molding process. The compressed air inflation technique is much more complex. The two shell halves are brought together and the air is trapped in the shell. The closing of the shell occurs in different stages as follows. A. The press closes until the edges of the half shells are not quite touching. B. At this stage, the internal platen area is isolated from the atmosphere by a rubber sealing ring around the periphery of the platens. C. Compressed air is also introduced at the required pressure to the platen area. D. The pressed platens are then brought together, so trapping the compressed air between two half shells and forming a pressurized core. E. The platens are then heated to vulcanize the rubber solutions and then cooled prior to core extraction. Owing to the fact the rubber compounds are permeable to gas, the balls would be out of specifications within a few months as the pressure is gradually lost. Pressurized balls are therefore sold in pressurized cans to maintain the ball's pressure until the cans are open. Stage 7. Core solution. The core is buffed to make a rough surface to act as a key for the solutions which is applied next. The cores are then coated with the rubber solutions in a barreling operation, in which cores together with a measured volume of rubber solutions are tumbled together, coating each ball with a uniform layer of solution. Stage 8. Fabric cover. There are two types of specialized cloth used in making tennis balls. These types are Melton cloth, which has high wool content, and needle cloth, which is cheaper to produce and can have a greater content of synthetic fibers. The said cloth arrive in 100-meter rolls. The cloth is then coated on its reverse side with a vulcanizing solution by means of one or more spreading operations. Dumbbell-shaped blanks are cut from several layers of cloth at once by an automated stamping machine. Two blanks are then used to cover each tennis ball. The edges of the blanks are also coated with vulcanizing solutions, which ultimately forms the seam of the ball. When the solution is dry, the covers are almost ready to place on the core of the ball. Two covers are carefully located onto the core by automatic machine. One covers centered along the core seam, the other at 90 degrees to the core seam. Stage 9. Molding. The ball is then placed in a molding press and heated, curing together the rubber solutions on the core and that on the back of the cloth. The heat and pressure is also cure the rubber solutions in the joint between the two covers and molds it into a smooth seam. The molded ball is cooled and removed from the press. This molding leaves the cloth very smooth and compressed, but with a ridge around it where the mold close upon it. Stage 10. Steaming closed upon it. Tumbling the ball slowly through a steam-laden atmosphere causes the cloth to fluff, giving a raised and softer surface. The ridge around the ball also disappears. Stage 11. Finishing. At the end, the balls are tested and graded. The brand name is also marked on the ball by a transferring process. Pressurized balls are usually packed into pressurized tins or tubes, which maintains the ball's pressure while stored. The balls are now ready for dispatch and use. We hope you enjoyed our today's video. If you did like this video, smash that like button and subscribe to our channel to stay up to date with the latest and interesting videos.